So we've already graphed parabolas in the general quadratic form of ax squared plus bx plus c by finding the vertex and then using the a value to develop a pattern and graph. And we've also done transformations of functions and graphed in the form of ax minus h squared plus k. And what we're going to do today is we're going to convert from one form to the other and then graph in this ax minus h squared plus k form or vertex form. And we'll start with this example of x squared plus 6x plus 4 and convert that using completing the square. Now, if you remember, in completing the square, the first thing we've got to have is a coefficient of 1 in front of our x, and we do. We can call f of x equal to y. It really doesn't matter. And what I'm going to do is I'm going to take and set that equal to, I'm going to isolate my variable terms because that's what we did when we completed the square. Remember though, typically when we solved by completing the square, we brought the coefficient term over. I'm going to do it a little bit different this time. We're going to isolate these variable terms by putting them in a parentheses. And we're going to remove the 4 from that parenthesis. Now we're going to complete the square of this term here. So in this case we get half of 6 squared, which equals 9. Now I'm going to add 9 to this term in parentheses, but I have to keep my equation balanced. So in order to keep it balanced, I'm going to subtract 9 from the quantity outside of the parentheses. Thus, I have y equals, this is now my perfect square, so that's x plus 3 squared by factoring minus 5, and now I'm in my perfect vertex form where I know this is h, k, and a is equal to 1. So I can go ahead and graph that by moving back 3, down 5, putting a dot, and then using my parent function, which is x squared, and that gives me 0, 0, 1, 1, 2, 4. And that's symmetric in both directions. So if I go over 1 and up 1, over 2 and up 4, and then do that on the other side as well, I get a picture of my parabola. And the problem also has to find the maximum or minimum value. This has a minimum value, and we're using our y value to state that. So the minimum y value in this case is negative 5. Here's another problem which is a little more difficult because our a term is 3, and as we said before, we need to make sure that a term, before I complete the square, has a coefficient of 1. So once again, I will isolate my variable terms, put my non-variable term on the outside. Now I'm going to factor so that I have a coefficient of 1, pull 3 out. I have x squared plus 4x plus 8. Complete the square, I take half of 4 and square it, which is 4. Now you'll notice this time going to add 4, but really what I'm doing, because this 3 is on the outside, is I'm adding 12 because I'd have to multiply this through. And to keep that balanced, I have to subtract 12 to the outside of that quantity. So that leaves me with y equals 3 times the quantity. This factors into x plus 2 quantity squared minus 4. And here I am once again in this vertex form. We graph that. We know a is 3. That's a y multiplier. H is negative 2, and k is negative 4. So I go over 2, down 4, put a dot, look at my parent function, which is 0, 0, 1, 1, 2, 4. Then I'm going to multiply my y values by 3, giving me 0, 3, and 12. So from this point here, I move over 1, up 3, do that on either side, and then over 2 and up 12. Do that on both sides, and now I have a much tighter opening in my parabola. Let's do another very similar example, just get some practice. We've got y equals, isolate those variable terms in the parentheses. Note once again, coefficient is not 1, so I'm going to have to factor. Complete the square, so take half of -2, square it, gives me 1. Add 1, but really, because of the multiplication, I'm adding 5. To keep it balanced, I have to subtract 5. Therefore, y is equal to 5 times the quantity of x minus 1, quantity squared, minus 5. I look at my parent function, which is x squared once again, 0, 0, 1, 1, 4, 2. Multiply all those values by 5 in the y column. That gives me a 0, a 5, and a 10. Whoops, I'm going to mess this guy up pretty bad. 0, 0, 1, 1, 2, 4. So I multiply that 4 by 5 and I get 20. And we'll take now and move over 1 to the right, down 5, put a dot, move over 1 and up 5, over 2 and up 20, and I'm pretty much out of room. It's going to be way the heck up there, so this is going to go here and then rise off the screen. And there's my parabola. So let's just do one more graphing where it's already in our standard vertex form, but we have an a term that's a fraction. Really no different. We have an a of a half, h of -3, k of -7. So we look at our parent function, x squared, 0, 0, 0, 1, 1, 2, 4. But we multiply our y's by a half, so that's 0, a half, and 2. Move over 3, down 7. Go over 1 and up a half. And over 2 and up 2. So again, we see this is a wider opening parabola. Now for a little word problem. We've got baseball height described by this equation. We want to know the maximum height it reaches and when does that occur. So we want to find basically, if this is the baseball, we want to find the vertex of the parabola. We can do this lots of different ways, go negative b over 2a, but since we're practicing completing the square, why don't we go ahead and do that. Isolate variable terms once again. get a coefficient of 1 by factoring the negative 16 out. Now the only problem is here we've got a nasty fraction, which is okay. So we'll take half of negative 5, square it, which gets us 25 over 4. So I'm going to take and add that 25 over 4 here. But with this multiplication, 16 times 25 over 4 gets me a total of negative 100. But since I've added negative 100 because of my multiplication, I have to add positive 100 to the other side. Thus I have y equals negative 16. Now when we factor this, because this is a perfect square, I need the square root of t squared and the square root of 25 over 4, which is just 5 over 2. So this factors into t minus 5 over 2 squared plus 100. Therefore, this is going to be a parabola. I don't need to graph the whole thing out, but I do know that if I move over to 5 halves and up to 100, and then I know since my a term is negative, this guy is going to go down. I have everything I need to do this graph. So basically, this reaches 100 feet high after 2.5 seconds. Lastly, let's review how to write an equation of the quadratic in vertex form. So we want to identify our vertex first. Looks like we're over 7 and up 1, 2, 3, 4, 5. And 7, 5 gives us our vertex or HK form. So we're putting this in vertex form, so y equals, we don't know the a value, x minus 7 quantity squared plus 5. Now, fortunately they give us a couple more points. I'm going to use this point right here, which is 6, 2. And we know that's just an x and y. I'm going to plug that in and find a. So I have 2 equals a times 6 minus 7 squared plus 5. Bring my 5 over, that's negative 3 is equal to negative 1 squared is 1. Therefore, a is equal to negative 3, and y equals negative 3 times x minus 7 squared plus 5. That'll do it for today. Make sure you do your Ed Connect, and fill out your lesson summary.